Hi everybody, it's Mrs. Dunn. We're solving applied problems involving maximum and minimum in this screencast. So one of my first examples I want to give you of an example of applications for this is to maximize area. So imagine that you're given certain fencing materials and you want to form a garden with this fence that you have. And you only have certain number of, um, you know, feet of fence and you want to maximize the area. That's an example of where you would be using quadratic functions. Often you'll see it in sports. The path of a basketball is parabolic, and you can imagine trying um, to get the best shot, maximize the height. Another example in baseball is like a home run ball or a soccer kick. And then there are a lot of examples in business. You often want to maximize profit and minimize costs. I'm going to go through two examples with you today. One is from business. So an example is this problem where we want to minimize cost. The designs for number one canines has determined that when X hundred portable dog houses are produced, the average cost per dog house is given by, and the function is written here, where C of X is in hundreds of dollars. How many dog houses should be produced in order to minimize the average cost per dog house? The key sentence in this example is the last sentence, the question. How many dog houses should be produced in order to minimize the average cost per dog house? When you see those words minimize, or if it was maximize, you're being asked to find the max or the min. And that's code for find the vertex. Well, let's talk about the vertex for this problem. The vertex in this problem is H and K. The vertex is HK, but in this problem, H is what and K is what? Well, they define H as X, and X is the number of 100 portable dog houses produced. And K is the average cost per dog house when X hundred portable dog houses are produced. So to answer this question, we're going to have to find H, or you can talk about it as X. We're asked to find the X part of the vertex. Well, we have an equation for that. The X part of the vertex, remember, is negative B over 2A. So we're going to plug in B, which is negative 4.2, and A, which is 0.1, into this vertex formula. And you get 21. So remember that's the X part of the vertex. Remember it says that is the number of 100 portable dog houses that need to be produced. So to answer the question, they should produce 2,100 portable dog houses to maximize the profit. Okay, let's shift gears. So what we want to do in the next question is we're going to talk about a rocket launch. So here's the example. A model rocket is launched with an initial velocity of 150 feet per second from a height of 40 feet. The function S of t equals negative 16t squared plus 150t plus 40. And that gives the height of the rocket in feet t seconds after it has been launched. Determine the time at which the rocket reaches its maximum height and find the maximum height. Just like I said before, that last line, determine the time at which the rocket reaches its maximum height. That word maximum is a clue that you need to find the vertex. Well, in this question, the vertex H is actually t, and t is the time. So we're going to plug b and a into our negative b over 2a formula. So we get negative 150 over 2 times negative 16. And that answer is 4.6875. So that means at 4.6875 seconds, it is at its highest point. Okay, now we were asked not only for when does it reach the maximum height, but what is the maximum height? Well, the highest point is the K part of the vertex, or what we get when we plug the X part, which is T in this case, into the function. So if we plug T into the function, we get 391.5625 feet. And that's the answer to the question. So when does it happen? At 4.6875 seconds. And how high is the rocket? 391.6 roughly feet. All right, good luck. Email me with all your questions.